Oh, hello there. Good to see you again. Let's go ahead and finish our conversation about significant figures. Last time, when we talked about significant figures, we talked about how we can identify the number of significant figures in a number, and we talked about how we determine how many significant figures to have when we are taking a measurement, depending on what tool we're taking and how precise the tool is. Today, let's talk about adding and subtracting with significant figures and multiplying and dividing with significant figures, and have a little practice at the end. Okay? So, as you can see, we're going to talk about adding and subtracting first. It's pretty easy once you get the hang of it. The idea here is that there's two rules. You have to make sure that all of your measurements are in the same units. So if one measurement is in grams, then they all have to be in grams. If you have, say, one measurement in grams, but then one of the other measurements is in kilograms, then you would have to convert the kilograms to grams. So not a big deal. More importantly, the second rule is that when you are adding and subtracting, considering significant figures, you have to make sure that your answer can have no more decimal places than the least number of decimal places in the problem. All right, that's a lot of words and it might be a little bit hard to understand, but just walk with me and I'll show you how this works. Okay, so let's look at our first example here. We have 11.44 grams plus 5.00 grams plus 0.11 grams plus 13.2 grams. Okay, so we're all in grams, so that's good. All right, so let's just go ahead and put this in our calculator. So here's my handy dandy calculator. So I'm going to do 11.44 plus 5.00 plus 0.11 plus 13.2. All right, and let's see what we get here. Okay, so our calculator gives me 29.75. Okay, so we'll just go ahead and put that on here. 29.75. Okay, now what we have to do is let's look at this second rule. The sum or difference may have no more decimal places than the least number of decimal places in the problem. Okay, so what we need to do is look at all of our numbers in the problem. Which number has the least number of decimal places? Well, 13.2 only has one number after the decimal point. Okay, so that means our answer can only have one number after the decimal point. So when you look at this, 29.75 as our answer, we could just knock off this 5 and it'd be 29.7. But we have to look at this 5 here and we have to consider rounding. And we know 5 or above, we round up, 4 or below, we round down. So technically, this answer should be, let's do this, should be 29.8. And then, of course, that would be grams. And there we have it. Okay, so this would be our correct answer. Okay, not so bad. Again, we're just have to make sure we remember that we're looking at the number of places after the decimal point. Whichever one has the smallest, that's the number of places after the decimal point our answer has to be. And of course, we have to consider our rounding. All right. Okay, so let's try this next one. So we have 2.34 meters plus 35.7 meters plus 24 meters. Let's go ahead and put that in there. 2.34 plus 35.7 plus 24, and that gives me 62.04. Okay, so let's put that in there. 62.04. 62.04. All right, now let's look at our rule again. Remember, when we're adding and subtracting, the answer can have no more decimal places than the least number of decimal places in the problem. So if we look at our numbers, we see that 24 is a whole number, so there's no decimal places. There's not even a decimal in the number, so that means that our answer cannot have any places after, or any numbers after the decimal point. All right, so this was pretty easy. it's just going to be 62. 62, and of course we're in meters, so 62 meters. Can't ever forget our unit of measurement. So there we go. There's our answer there. All right. So again, adding and subtracting, it's pretty easy. All that we have to remember is our main rule here, that our answer has to have the same number of decimal points, decimal places, as the least number of decimal places in the problem. All right, let's move on to multiplying and dividing. Two rules again, pretty much the same thing. First rule, our measurements have to be in the same units. So again, if you have, let's say one unit is in centimeters, then they all have to be in centimeters. Or again, if you have, let's say, centimeters, but one of them is in meters, then you would have to convert the meters into centimeters. Or you could go the opposite direction and convert the centimeters into meters. Doesn't matter as long as they're all in the same unit. Okay, now here's the big difference. In multiplying and dividing, our rule is that our answer has to have the same number of significant figures as the least number of significant figures in the problem. So we're not looking at how many places after the decimal point. We're looking at total significant figures in the problem. Okay? Let's bring my calculator back up. All right, so here we go. Let's look at the first one. We have 0.304 centimeters times 73.84168 centimeters. Let's put that in the calculator. So 0.304 times, let's see, where's my times? And we're 73.84168. All right, so let's see what the calculator tells us. Holy cow, that's a lot of numbers. So we have 22.44787072 as our answer. Now, remember, our rule is the number of significant figures should equal the least number of significant figures in the problem. Let's look at this. How many sig figs in this first number? We have 3 sig figs here. How many sig figs in the second number? 1, 2, 3, 4, 5, 6, 7. So our answer can only have 3 significant figures. Well, if we look up here at our answer in the computer, 22.44787072, that's a whole bunch of them. We only need 3, so we're just going to take the first 3. 22.4, the 4 after it means we don't have to worry about rounding, so it's just 22.4. Let's not do that. Let's put it right there. And we are in centimeters, so there's our answer, 22.4 centimeters. Not so bad, right? Let's look at this next one. My calculator keeps disappearing on me. I got to figure out how to change that. We have 0.1700 grams divided by 8.50 grams. Let's try this a little bit differently this time. Let's determine the number of significant figures in each number before we start. So the first number, 0.1700, these zeros are significant because they follow the decimal point and a non-zero digit. So we have 4 sig figs in our first number. Our second number, 8.50, again, this 0 is significant because it follows the decimal point and a non-zero digit. So we have 3 sig figs. So our answer can only have 3 sig figs. All right. Honestly, I feel like what we just did is the easiest way to do this. That way you're going ahead and determining how many sig figs your answer is going to have, and then you can just go ahead and go from there. All right, so let's just type this in. So we have 0.1700, and we're going to multiply that by 8.50. So here's our answer. And remember, we can only have 3 sig figs. Right, so we have 1.445, 1.445. So we only need 3 sig figs. So we want to stop right here after the second 4. But since this is a 5, that means we have to round up. So we're going to change that. Let's just do this. Let's just do it as 1.45 because we're rounding up. Right? Remember, we're rounding up. and we're in grams. Okay, so here is our answer. Let's go ahead and make that red too to show that this is our answer as well. All right, again, pretty easy. It's just remembering this part of the rule here, that when we're doing multiplying and dividing, we're talking about the smallest number of sig figs in the answer equal to the smallest number of sig figs in the problem. Okay? Let's do a practice run here. First of all, how many sig figs in each of these? I'm going to do a couple of these, and then I'm going to stop, and I'm going to let you do the rest of them, and then we'll do both of these together. Okay? So let's do this. So for this first one, we have 9,000.0. This decimal point makes all of these zeros significant. So we have 1, 2, 3, 4, 5 significant figures. How about the next one? 25.098. The 0 is in between two non-zero digits, so that 0 is automatically significant. So we have 2, 4, 5. Again, let's try one more. We have 0.0003. These zeros, even though they come after the decimal point, since there's not a non-zero digit before any of these zeros, that makes all of these zeros not significant. So the 3 is the only number that's significant. So we have 1 sig fig there. Okay? Now, I'm going to stop here and let you guys practice on the rest of these. Let's move on to our addition and subtraction here. Okay? Let me bring back my calculator. Alright? So we have, first of all, we're adding. Alright? So remember, our rule for adding is our answer has to have the same number of decimal points, or decimal places, as the least number of decimal places in the problem. So let's look at this. How many places after the decimal? We have 3 here. How many after the decimal here? We only have 1. So our answer, we know our answer can only have one number after the decimal point. So let's go ahead and punch this in. So 0.203 plus 19.2. So that gives us 19.403. Remember, we can only have one number after the decimal. And since the number after 4 is a 0, we don't have to worry about, let's see, we don't have to worry about rounding. So I lost that. I wasn't paying attention. Where was that? 19.4. Yep. 19.4. And no unit of measurement, so we don't have to worry about that right now. So there's our answer there. Okay. We have the same numbers as one of the problems we did in the last slide, but now we're dividing instead of multiplying. So let's try this out and see what we get. So again, we're dividing, so we're looking at the lowest number of significant figures in the problem. Our answer has to equal that. So of course the 0.304, only 3 sig figs, versus this other number has, like, let's see, 2, 4, 6, 7 sig figs. So we know we only need 3 sig figs. So let's bring our calculator back. Let's punch that in. 0.304. 84168. Let's see our answer. Holy cow, that's a whole bunch of numbers. Alright, so we have a whole bunch of numbers here, but our answer can only have 3 significant figures. So when we look at this, let's look at this. 0.004116916083117. How many of these numbers are significant? Well, remember, if there's no numbers in front of these zeros, these first zeros are insignificant. We still have to add them as part of our answer, right? They're still insignificant, but we have to add them. So we look at the next 3 digits. So 4, 1, 1. But since this is a 6, we have to round that up to a 2. So let's put our answer. So 0.00412 is going to be our answer. So 0.00412 is going to be our answer. Let's do that. Let's get rid of that first. So there you have it. Not so bad. Again, the more you practice, the easier it's going to become. Now, lastly, I just want to say, you might be asking yourself, why do I have to do this? What is the point of doing this? As a matter of fact, that is the question of the year. Why do we do this? Remember, this all has to do with how precise the measurements are, right? So let's take an example. Let's say I am taking a sample of one substance and I'm adding it to a sample of another substance. And let's say that the first substance, for some reason, it's measured in grams and it's measured with one triple beam balance that only goes to 1/10 of a gram. Versus the second substance, maybe for some reason it's been measured with a different triple beam balance and it goes to 1/100th of a gram. That's the smallest increment of measurement. Well, you wouldn't want to add those two together and just come up with an answer willy-nilly, because that's not going to be very precise, because you have to go with the least precise measurement. If you've got a measurement that goes to the 10th versus a measurement that goes to the 100th, well, the one that's 100th doesn't equal out to the one that's measures to the 10th. Okay, so again, you still might not understand it very well, but just remember, we're talking about how precise the measurements are depending on the tool that you're using. Okay, we'll actually do some stuff in the lab that kind of goes along with this, so don't worry. All right, just keep practicing and you will be awesome at it. All right, thanks for listening. See you. Bye.